In the past video of trigonometric integrals, I did examples on single trigonometric functions. In this video, I will introduce integrating two or more trigonometric functions. I'll also do examples where the coefficient of x and sine x, tan x, cos x is not equal to 0. So let's consider this example. So if you're given something like this, and you're asked to integrate it, what do you do? In this case, you want to try to find a way to write sine squared 4x as a trigonometric ratio that has no power. So what we're going to do is we're going to use the fact that this is going to be cos squared. We know this trigonometric ratio, right? It's the one that's written like this in general: 1 over 2, 1 minus cos 2x. So I'm using it here. So in the place of x, we're going to put 4x, right? So that's going to be, this is going to be 8x. As a result, we will end up with having something that looks like this: 1 minus cos 8x dx. And then we can take out 1 over 2 because it's a constant. It's going to stand just behind the integral sign. And then now we will just follow our conventional rules of integration to find the integral of 1 minus cos 8x. So we're going to have 1 over 8 multiplied by the derivative of 1, the integration of 1 is going to be x, minus the integration of negative cos 8x is going to be sine 8x, divided by the derivative of the inside part. The derivative of the inside part 8x is 8 plus c. Let's multiply it out for the sake of completeness. So 1 over 2 multiplied by sine 8x over 8 is going to be 1 over 16 sine 8x plus c. That's how you would do this question. Let's do the second one. Now imagine you were given something like this. You can go ahead and try to do it. Here, we're still going to be utilizing the same line of reasoning, which is to first write cos squared 5x as a trigonometric ratio that has no power. 1 plus cos 2 times something. In this place here, we're going to put 5x. In general, remember, cos squared x is equal to 1 over 2 multiplied by 1 plus cos 2x. So in the place of x, we put 5x. So let's write this here. This is going to be 1 over 2, 1 plus cos 2 times 5. 2 times 5 is going to be 10. So let me just write 10 here. 10x dx. And then we're going to multiply out 1 over 2. Not multiply out, we're going to put 1 over 2 in front of the integral sign and be left with 1 plus cos 10x inside dx. So let me remove this part here. Okay, now we are left with something very easy to deal with here. So basically we're going to perform integration. The derivative, the integration of 1 is going to be x, because we are integrating with respect to x. Keep on saying derivative. And the integration of cos 10x is going to be sine 10x. And then we're going to divide by the derivative of the inside part, 10x. So the derivative of 10x is 10. Then we're going to see plus c. And then multiply out. 1 over 2 multiplied by x is 1 over 2x. 1 over 2 multiplied by sine 10x over 10 is 1 over 20 sine 10x plus c. That's how you do this one. Looks similar to the one we did previously. This means that in every occasion where you are asked to solve for a problem like this, you're going to utilize this line of reasoning. Okay, now let's go to the third example. In the third example, you're given two different trigonometric ratios. This too requires the same set of principles that you've already learned. Sine squared x is equivalent to 1 minus cos squared x. And you will see why I chose this one in particular, this trigonometric ratio in particular. 1 plus, this is supposed to be 2x here. We just did it in the previous example. This is going to be 1 plus cos 2x. So as you can see, we are still equating these trigonometric ratios to their trigonometric ratio equivalents that have no power. And by now you can already see that you need to know your trigonometric identities, you need to know your compound angle formulas, and you also need to know the fact that sine squared x plus cos squared x is equal to 1. So if you're dealing with trigonometric integration, you've got to know your compound angle formulas and your trigonometric identities. So let's continue. Okay, so now 1 over 2 multiplied by 1 over 2 is going to give us 1 over 4. And we're going to put 1 over 4 outside the integration sign. And then we will be left with 1 minus cos 2x multiplied by 1 plus cos 2x. This resembles the form 1 minus x multiplied by 1 plus x, where in this case cos 2x is in the place of x. And we know that our answer is usually, or is always, 1 minus x squared. So now we're going to do the same thing here. Our answer will be 1 minus something squared dx. In the place of x, we will put cos 2x, which will then look something like this. 1 over 4, 1 minus cos squared 2x dx. Now when we have this, we know that 1 minus cos squared 2x is equal to sine squared 2x. This is because of the fact that sine squared x plus cos squared x are both equal to 1. That's their sum when you add them. Okay, so if you manipulate 1 minus cos squared x, you will find that it is equivalent to sine squared 2x. Okay, now let's continue again. Sine squared 2x is the same as 1 over 2 multiplied by 1 minus cos 2, and then we're going to have something here. That something is this one. It's 2x. So if we put 2x here, we're going to have 2 times 2x, which is going to be equal to 4x. So let's write 4x. Okay, now that we have this, we can further simplify our thingy to be 1 over 8, because 1 over 4 times 1 over 4, 1 over 2 is 1 over 8. Then we have inside 1 minus cos 4x dx. Then this becomes 1 over 8 multiplied by the derivative of x, of 1 is x. The derivative of cos 4x is sine 4x. I keep on saying the derivative. This is an integral. The integral of 1 is x. The integral of 4x is sine x divided by 4. This 4 here comes from the differentiation of 4x plus c. So let me explain it again. The integral of 1 gives x. The integral of cos 4x gives sine 4x over 4 plus c. That's how you find this one. You can multiply it out for the sake of completeness, but then it's also okay to leave it this way in this case. Now let's go to the last question. Last question is not straightforward, and it's my favorite. So here you're given cos squared x multiplied by tan cubed x dx. So here, as you might expect, we have to change before we multiply. We have to change tan x into sine cubed x over cos cubed x, and you can easily tell that there's going to be some cancellation taking place here, but then we will be left with 1 cos x at the bottom in the denominator. So as a result, we will end up having something that looks like this: sine cubed x over cos x dx. So here, what we do is we do what we normally do when we have a trigonometric ratio with the highest power. We manipulate it. So we'll write sine cubed x as sine squared x times by sine x, and then we're going to divide by that cos x. Now we have something to work with. If you look at sine squared x, again it's the highest power here. Let's try to manipulate it. We can write sine squared x as 1 minus cos 2x multiplied by sine x divided by cos x. Now we have identified an inside part, this one, 1 minus cos squared x. So we're going to let u be equal to the trigonometric ratio that has an inside part. And how do we identify an inside part? The inside part is the one that is the expression that was derived from the expression that had the highest power. Okay, so now let's do the derivative. That's going to give us negative sine x dx. Dx is going to be equal to du over negative sine x. Let's substitute everything. Okay, 1 minus, in the place of u squared, we're going to have cos squared x, we're going to have u squared because u is equal to cos x. Sine x over u. In the place of dx, we will have du over negative sine x. And they will cancel out. All we will be left with is 1 minus u squared over u du. This is easier to integrate, as you will see. Let's separate our fraction into two individual fractions. So u will be shared amongst 1 and u squared. So we will have 1 over u minus u squared over u du, which will be equal to 1 over u minus u 2 minus 1. There is a 1 there, so 2 minus 1 is 1 du. Now let's write the final expression. It's not really the final, but then it's almost like a penultimate step before we perform integration. So we will end up with 1 minus u minus u, 1 over u minus u du. And then here, we know that the derivative of 1 over u is ln u. And don't forget to put the negative sign here, because the derivative dx had looked like this. It looked like this. So this negative multiply the whole integral in the previous slide. Okay, so that's why we have a negative here, but I forgot to account for it in the last step before this one. So the derivative of 1 over u is ln u is the negative minus the integral. This is the integral. I don't know why I keep on saying the derivative. So 1 plus 1 divided by 1 plus 1 plus c. The integral of 1 over u is ln u. Bear with me here if I'm making some mistakes in terms of how I pronounce things. Okay, so this is going to be ln u plus, because we are multiplying out with a negative, u to the power 2 over 2 plus c. Now we'll substitute back. We know that u was equal to cos x and still is. So we have cos x here plus cos squared x over 2 plus c. And that's how you do these questions. If you like my video, please make sure that you leave a comment and share it with friends. Don't forget to also subscribe. Cheers. See you in the next video.